Right now, at this exact moment, if you own a Toyota, there is a very real chance that a mechanic somewhere is preparing to hand you a repair estimate that will make your stomach drop. And the terrifying part is not the number on that paper. The terrifying part is that the entire diagnosis is a lie, built on a visual trick so convincing that even experienced technicians either fall for it or pretend to fall for it, because the alternative destroys a business model worth billions of dollars every single year. Here is what happens. You pop your hood one morning, and you see it. Fresh, dark, steaming engine oil sprayed across the entire passenger side of your engine block. It is not a drip. It is not a seep. It is a violent, pressurized coating of oil that has painted every surface within reach. Your heart sinks. You already know this looks catastrophically bad. You take it to the shop, the mechanic wipes a finger across the block, shakes his head slowly, and says the words every Toyota owner dreads: head gasket, maybe even a cracked block. Could be $3,200. Could be more. Could be a total loss. And you believe him, because the evidence is right there. It looks exactly like what he says it is. Except, it is not. Not even close. What you are actually looking at is a $12 part failing in a very specific and visually dramatic way, and the repair industry has known about this for over 2 decades. To understand why this works as a scam, you need to understand what is actually happening inside your engine at the mechanical and physical level, because once you see it, you can never be fooled again. Your engine runs on pressurized oil. The moment you turn the key, your oil pump begins forcing oil through every internal gallery, bearing surface, and channel at pressures ranging from 25 to 80 pounds per square inch, depending on RPM and engine temperature. That oil is not gently circulating. It is being driven with serious hydraulic force through a closed system. Now, threaded directly into that pressurized oil gallery, screwed right into the engine block itself, is a small component called the oil pressure sending unit. Some people call it the oil pressure sensor or the oil pressure switch. It does one job. It reads the internal oil pressure and sends a signal to your dashboard gauge or warning light. That is its entire purpose. In the original brass and steel designs that Toyota used through most of the 1980s and early 1990s, this sender was a robust, fully sealed unit. The internal diaphragm that read oil pressure was housed in metal, and the electrical connection was a simple, durable spade terminal. These units lasted the life of the engine without a second thought. But somewhere in the late 1990s, as Toyota, like every other manufacturer, began aggressively cutting manufacturing costs to chase margin on their vehicles, the oil pressure sending unit transitioned to a plastic-bodied design. The housing that protects the electrical connector became injection-molded plastic. The internal rubber diaphragm that separates the pressurized oil from the electrical sensing circuit became thinner, cheaper, and more vulnerable to the thermal cycling that every engine experiences. Heat up, cool down, thousands of times over the life of the vehicle. That rubber diaphragm fatigues. It develops a microscopic rupture. And when it does, the full internal oil pressure of your running engine now has a direct path straight through the sensor body and out through the plastic electrical connector. Think about what that means physically. You have oil at 60, 70, sometimes 80 psi, and it now has a breach in the seal leading directly to the outside of the engine. That is not a drip. That is a pressurized spray. The oil follows the path of least resistance, which is along the electrical harness that plugs into the sensor. It travels along the wire, it follows gravity and wind and heat convection patterns inside the engine bay, and it deposits itself in a massive, catastrophic-looking film across the entire engine block. The spray pattern covers the valve cover, the exhaust manifold, the firewall, the oil filter housing, everything within range. It looks exactly, with no exaggeration, exactly like the kind of oil migration you would see from a failed head gasket or a cracked block. The visual signature is nearly identical. And a mechanic who is either undertrained, dishonest, or simply operating on commission has every incentive to call it the expensive thing rather than spend 90 seconds investigating the $12 thing. This is not an accident of history. In the early 2000s, as these plastic sender units started failing on aging Corollas, Camrys, Tacomas, and Tundras at scale, Toyota dealership service departments began logging the repair patterns. The internal service data was there, the misdiagnosis was there. The correlation between the oil spray pattern and the failed sender was documented in the technical service community. But there was no recall. There was no service bulletin pushed to customers. There was no proactive communication, because a $12 sensor repair that takes 5 minutes generates approximately zero revenue. A head gasket job, however, is a 15 to 25-hour flat-rate labor operation. At a dealership labor rate of $150 per hour, you are looking at $2,000 to $4,000 in labor alone before a single part is purchased. That is not a coincidence. That is a business decision. They did not build this failure mode to last. They built it to be misdiagnosed. And the dealership network, whether through formal coordination or simply through the shared financial incentive of every service writer who works on commission, turned this incredibly simple, highly visible seal failure into one of the most profitable misdiagnoses in automotive history. Now here's the proof that makes this undeniable. Fleet operators, the people who run hundreds of Toyotas simultaneously as work vehicles, have documented this failure exhaustively because they cannot afford to be fooled. Municipal fleet records from multiple American cities show that oil pressure sender replacements on one MZFE and two AZFE Toyota engines spiked dramatically between 100,000 and 150,000 miles, and in every documented fleet case, the presenting symptom was a massive external oil leak with no internal pressure loss, no coolant contamination, and no combustion byproduct in the oil. In other words, the three diagnostic markers that definitively confirm a head gasket failure were absent in every single case. The engine had perfect compression. The coolant was clean. The oil had no milky discoloration. The only failure was the $12 sender. Commercial Toyota operators in Japan, where these vehicles are worked far harder and far longer than in North America, have documented sender diaphragm failure as a routine maintenance item at high mileage, replacing the unit proactively during oil changes, specifically to avoid the cosmetic oil spray that triggers misdiagnosis at shops unfamiliar with the failure mode. So here is exactly what you are going to do today. Before you let anyone touch your engine, first, with the engine cold and the ignition off, open the hood and locate your oil pressure sending unit. On most Toyota four-cylinder engines, including the one AZFE, two AZFE, and one NZFE found in Camrys, Corollas, RAV4S, and Tacomas, the sender is located on the engine block near the oil filter, typically at the rear of the block near the cylinder head junction. On the V6 engines, including the one MZFE and two GRFE, it is often on the front of the engine near the timing cover. It looks like a small plastic-tipped cylinder, roughly the size of your thumb, with a single wire connector plugged into the top or side. If there is oil around the connector and oil tracking down the wire, you have found your culprit. Second, unplug the electrical connector. There will be a small plastic tab you press to release it. The connector may be soaked in oil, which is itself diagnostic confirmation. Set it aside and clean the area with a rag. Third, use a 24mm deep socket on a long extension and your ratchet to turn the sender counterclockwise. It will break loose with moderate force. Back it all the way out and inspect the threads on the block. Clean them with a clean rag. You will likely find the old sender's rubber diaphragm is visibly cracked, hardened, or deformed. Fourth, take the new sender. You can source it at any auto parts store. The part number for most Toyota applications is available at the counter. Genuine Toyota units are under $20. Quality aftermarket units are $12 or less. Apply a small amount of liquid thread sealant, not PTFE tape, liquid sealant, to the first two threads of the new sender. Thread it in by hand first, then torque it down firmly with your socket. You do not need a torque wrench. Snug plus a quarter turn is sufficient for this application. Fifth, reconnect the electrical connector until it clicks. Start the engine. Watch the oil pressure gauge come up normally. Check around the sender for any seepage. There will be none. The repair is done. The massive oil hemorrhage that a shop wanted $3,200 to fix is permanently solved, and you spent $12 in less than 5 minutes. This is the part where I need you to understand something. The shop that quoted you $3,200 either knows exactly what this failure mode is and chose the more profitable diagnosis, or they are so undertrained that they should not be touching your vehicle. Either answer is a reason to walk away and never return. And either answer is a reason to share this video right now, today, before you close this window, because your brother, your mother, your neighbor, your coworker, they all have Toyotas. They are all one oil spray away from being handed a $4,000 estimate for a $12 fix. Sharing this video is not doing me a favor. It is protecting the people around you from being robbed in broad daylight with a clipboard and a shop uniform. Subscribe. Hit the notification bell. Because what I am releasing next will make this video look mild. I have documentation from inside a major dealership group showing exactly how extended warranty claims on transmission failures are systematically denied using a specific language trick buried in the fine print, a trick that voided over $40 million in legitimate claims in a single fiscal year, and I have the internal training memo that taught service advisors how to do it. You are going to want to see that the moment it drops.